Hi, my name is NADZZRIN ZAMLI. My metric number B0516. Exoskeleton is an internal frame that can be worn to support. First problem statement is no detailed data is provided when using the. Okay, for my objective and scope, the first objective is to analyze current mechanism regard to arm rehabilitation product. Second one is to analyze the required amount of spring constant that represent the sling on the counterbalance arm sling. And the third one is to provide detailed data that aid patient to experience an effective rehabilitation activity on the fabricate counterbalance arm sling. For the scope, first one is reviewing the existing counterbalance arm sling and equipment that bring use at the rehabilitation place through the design, shape, and exoskeleton frame. Generate the mathematical solution to easier the rehabilitation process. The third one is design counterbalance arm sling using SolidWorks software. The last one is perform motion study analysis on the design for the behavior of the critical parts using the SolidWorks software. This is some of literature review of my research. This is some of literature review of my research. Okay, for this slide, I will explain about methodology. This is flowchart process of my product, and for my objective to analyze the current mechanism regard to arms rehabilitation product, I will use method critical analysis on my literature review. So the second one is to analyze the required amount of spring constant that represent the sling band on counterbalance arm sling. I will use experiment on rubber sling band. And the third one is to provide a detailed data that aided patient to experience an effective rehabilitation activity on the fabricate counterbalance arm sling. I will use SolidWorks motion study analysis. This is how to set up experiment to find K constant. First, need the tape, marker, weight scale, water bottle, luggage weight, and the Evo band sling rubber. We have three types of sling rubber: the blue one, the yellow one, and the red one. And then this is the formula to calculate the spring constant, as you can see in the slide. This is how we want to set up our motion study analysis. We need to set up the springs. We have three springs that will be used in this research. The first spring K is 507.94, which is the yellow one. The second one is 550.28, which is red one. And the third one is 733.7, which is the blue one. So we need to put the force into the process the product, which is 50 Newton, and also we need to put the motor on the product to move the bottom bed of the product. This is the result and discussion for my objective 2. The product is in 90-degree angles, and we have to calculate the C, which is hypotenuse, and we got the value which is 0.234 meters, and the total length for upper part is 0.43 meter, while the total length for lower part is 0.30 meter. We will use three type of rubber to make an experiment for sling rubber to get a K constant. We use the formula total force equal to K times total elongation. As you can see in the slide, we have got three type of color, which is yellow, the red one, and also the blue one. First step is we need to calculate the force that needed to perform this test or the experiments. So the F1, and we got the 11.77 Newton, The F2 we got 16.28 Newton, while F3 21.58 Newton. F4 we got 25.99 newtons, and the last one F5 we got 31.58 newtons. This is after we put the force into our experiment, and then we got the X value, which is the new elongation minus the elongation, normal elongation. So as you can see, this is the result that we get from the experiment. So we got 5 value from the yellow band, and the 5 value from the red band, and also the 5 value from the blue band. Total force for this experiment is 19.81 Newton. As you can see, we can get generate 3 graph from the 5 of each rubber band that we got from the previous slides. So we will use the equation y equal to mx plus c to get the value of k spring constant, and from the first graph we got the k1 as 507.94 Newton per meter, and the second one is a K2, which is the red one. We got 550.28 Newton per meter, and the third one we will get the K constant, which is 733.7 Newton per meter. So we will achieve our objective, which is to find value K of each spring constant from each sling band. Okay, for the next slide, I will explain about the objective 3 that I run the test on a motion study analysis. And as you can see, the graph that we generate from the motion study, the first one that we use a force 50 by using K1, which is 253.5. We get the value from each one of the graph, and the displacement that we calculate is from joint point 1 to joint point 2 at the spring, and we'll use as first condition, which is 0 angle, and the time to perform the motion is 2 seconds. 15 Newton force had been selected due to the average force that being tested on the hemiparesis patient. So that's why we use 50 Newton for the force. And this is the second result from the motion study analysis that we get. We will use angle 15, as you can see and in the picture, and the displacement that we will calculate is from the point joint spring 1 to the point joint spring 2. So the K1 we will generate the graph like this, and the K2 we will generate the graph like this, and the third one we will get the graph like this. And the last result from my objective 3 is to put the angle on my product, which is at the picture, from joint A to joint B. We put the angle at that place to calculate the displacement of the product that can be moved while doing the rehabilitation process. So we still use the 50 Newton force to perform this study, and the time to perform this study is 2 seconds. We use K1 as a 253.5, while K2 is 275.14, and the next one is we use K3 as a 360 0.83. After ny graph is generated from the motion study analysis, we put all the value that we get from the graph into the one of the table. So we will get the displacement table with angles times spring constant. As you can see, 0 angle and the 15 and also the 30. While the K1 and K2 and K3 is in tables. The K1 is represent the yellow, while K2 is represent the red sling band, and the third one, K3, will represent the blue sling band. When we got a 0 angle, while we use a K1 as a spring constant, we will get a negative 95 millimeter for their displacement. While when we use the 15-degree angle, while we perform a K1 as a spring constant, we will get 93 millimeter as a displacement, and the next one is 30. After we use a K1 as a spring constant, we get a negative 87 millimeter. And we go to the second one is a K2. We will perform with 0 condition. We will get a negative 93 millimeter. And the next one is 15. We will get the negative 85 millimeter, and the last one is 30. We will get the negative 83 millimeter while we perform by using the K2. And the last one is while we're using the K3 as a spring constant with 0 angles, we will get a negative 91 millimeter. For the 15, we will get the 81 millimeter, and then for the 30, we will get negative 75 millimeter. As we perform the motion study analysis and we got the result from that experiment, we will conclude the more angles that we perform on the product with the higher K constant, we will get the less displacement that will gain from the motion study. While when we use a 0 angle and we will use a K1 as a spring constant, which is 253.75 as a spring constant, we will get the longer displacement, which is negative 95 millimeter. So the objective one for my product is to analyze the current mechanism regard to arm rehabilitation product. So the result is I able to make a complete design and analyze by using the SolidWorks. The second one is to analyze the required amount of spring constant that represent the sling on the counterbalance arm sling. As a result, I get a value of K that can be determined when using the experiment above. So we can get the value of K to use in the SolidWorks to perform motion study analysis. So the third one, this is the last, to provide a detailed data that aided patient to experience an effective rehabilitation activity on the fabricated counterbalance arm sling. As a result, I had the analysis, which is the result obtained from this research is when the more angle applied into the design while using the counterbalance arm sling, the less displacement will occur, and the increasing value of K will also affect the displacement of the product. The degree of angle play important part when we using assistive device. My last slide part is a recommendation. I will recommend to use multiple force to get more or generate more data of a displacement angle and the trace path. Due to the COVID, I will manage to use only average force, which is 15 Newton. The second point is I want to detail the table, create the detailed tables to improve the rehabilitation process. If we can get the more force that we can perform in a motion study, and we will get the more and accurate data to easier the hemoparalysis patient to do a rehabilitation process. Thank you for listening. I hope to see you in the Q&A session. Thank you so much.